Welcome to the sixth part about SED. Streamline Editor is a very powerful tool. I have probably used it for the last few years many times throughout scripts. With that, you have power. Let's go and have a look. Let's start again with a very straightforward example. Test. Here we're going to pipe the input to the set command. We're going to make a small change. We're going to substitute test, and remember that the substitute looks very similar in syntax to what we've seen in VI before. Substitute test to hello Percona. Okay, so we've made a substitution from one bit of text to another bit of text, from to, with the substitute command. Now, if we did the same, but we specify it this way, the echo will still output the same, but we're not substituting anything because there's no uppercase T here. So we could say case insensitive, and that works. We could also substitute T. Now look how it's substituted the first T and then still outputted the rest of the text. We can say substitute globally or generally each T. Hello Percona. Yes, the middle bit of test. Hello Percona. T and T. Replaced globally 2 times. Even if we swapped it to T, it would still work because we're working case insensitive. How about we have test, and we want to replace the space with 2 spaces. This works too. How about if we're not sure if there is a space or a tab? This works too. A space or a tab, which is identified by using backslash, which is an escape character, T. Tab is identified by backslash T. So either a space or a T, and we can see that it's an OR setup by the brackets, and it works. How about if we say, if you see an T or if you see an E? That worked, but only for the first T. Notice how there's 2 spaces here instead of the T. Again, this is because we're searching just for the first occurrence. Now we've done it globally, and look at the change. It's because every T and every E, which match here, have been replaced. Very handy. How about if we say this? Here we say we need to have at least 1 occurrence. A little bit complex to follow exactly how it came up with this. You would have to go and analyze it. This, on the other hand, will do the following. Here we're looking for any number of TEs, in other words, TE from the test, and change it by 2 spaces. Again, if we do this globally, the TE matches, then the TE matches in the next one, and this T matches too. So we get a lot of spaces. And there would be spaces at the end here for the final matching T. How about if we look for any character and replace it by an underscore? Remember from our previous part, and if you haven't seen that yet, I'd recommend you go and have a look at it, that a regular expression, in this case a dot, means, for this particular case, any character. Great, so all characters globally are replaced. Let's do it without the global option, and indeed only the first one is replaced. If we match two any characters, then the replacement has happened. Notice we're swapping the first two characters to an underscore. And this has worked too. We can also use other dividers. For instance, like this. I personally like using these a whole lot more because let's say that we have our current path and we try and change home or the full path. Look what's happening. This is not only very confusing to read, but it will not work. It fails because it's getting confused with all these slashes. And that works fine. Of course, we haven't really replaced anything because we're just replacing this text with this text. But it goes to show how these, they're not pipes in this case, but how these pipe symbols can be very handy when using set. By default, I nearly always use these instead. Unless you have some text that has these bits in it. Let's see how that works. We're just going to replace something that isn't there. But now if we try to do this, it wouldn't work. How about if we escape it? Yes, this works. So we have escaped the character and replaced it by an underscore. The same can be done when you had this path. But notice how complex the syntax would look. So we're going to take our previous command here again. And this time we're going to escape all the forward slashes that are not really part of the set command. They're just forward slashes of text we need to replace. And that works too. But who would like to read this? This looks much easier and straightforward. Let's have a look at some more things that set can do. Our test file from the previous part is still there. Let's copy this test to test2. Let's have a look at the file. And now we're going to use set directly. We're going to inline replace one with underscore for the test2 file. Okay, so that has executed. Let's have a look at test2. And indeed, inline replaced straight away in the file itself. These have now become underscores. If we rather, let's make a copy again. If we rather want to make sure that we still have a backup copy, then we can specify the syntax as follows. Inline replace and the extension. Let's have a look. And there is now test2.back, which is a backup. And there is our inline modified file, which has the underscores. So the -i is very powerful, but you might want to keep a backup copy just in case your set was incorrectly written. Let's start doing some work on this file, and we can just specify this directly. We don't need to get each time the output. We want to replace 2 by an underscore, and we want to do so globally for the file test2. Okay, so this works. Let's just make a fresh copy of test to test2 so we have a clean file. And indeed, all the 2's have been changed. Now, let's do the same for A. So here our A's have been changed. Now let's say that we would like to keep a copy of whatever it is we've matched. Then we can specify it as follows. We need to escape these parentheses with a backslash in front of them. Otherwise, they would just be interpreted as literal parentheses. So we're going to save this, and we're going to say match me any part of text afterwards, so any character, any amount of times, and replace this by \1. Now what \1 means is the first time that this syntax was used. We can also do the same here and say \2. So now what we're going to do is we're going to match an A here, which will match that A here, and then any text, which will match this. This will be designated 1 and this will be designated 2. And we're going to put 2 first and then 1. Let's see if this works. Sure enough, it's put A at the end and the rest in front. So we could also do something like match me A and then anything else. And then just replace all of that together with \1, which is just the A. And indeed, now there is just the A. We can also use the other syntax that we've seen from the previous regex part. For example, find me anything that starts with A, then any other text, and then you'll come to the end of the line. That's sort of not really necessary here, but I'm putting it in as a bit of an example to make it a bit more clear. And change that by __. Okay, so anything that started with an A, our original file, anything that started with an A has now become __. We've replaced everything. If we simply had done it this way, then of course just our initial A would be replaced, but we haven't really searched for anything else. We can also do, if you see any C towards the end of the line, where not towards the end of the line, but literally at the end of the line or before the end of the line, then replace it. And indeed, it has done so. Let's have a look again at our input file. And this time we'll use a pipe just for good measure. And we'll change 1 to 2, or 1 to _. And we'll introduce a second command here. Now, the syntax here is the same as bash, as we've seen previously. But this time we're working in set, and set uses the same syntax. And we're going to swap 2 as to 2 underscores, or maybe just to 1 underscore as well. So we could specify it like this or like this, because it's the last command, it's not really needed. Okay, so any 1 and any 2, these are 2 different substitute commands, have happened. Now, how could we have written this easier? Well, we could just say 1 or 2. And this has the same effect. Finally, I want to show you something really nice my colleague Ramesh has found. Let's have a look at this file. Let's say we want to inline replace or inline work. I shouldn't say replace, but inline work. And every 3 lines we want to read the test2 file and insert it into test. So what's going to happen is every 3 lines in the file test, the test2 file is going to be read in and inserted. So let's have a look at test. And indeed, it's a pretty large file by now. Very powerful if you want to interleave some SQL into a particular SQL file. For example, you might have found a few crashing queries, and you could write something like every 5 lines into my test case, I want to insert my crashing queries. Of course, I cannot execute this here because I do not have those files available, but every 5 lines into testcase.sql, leaving whatever is there already, insert my crashing queries. Why would this be handy? If we start randomly replaying this test case, then these crashing queries would be hit very regularly. Of course, if this file is very large, we would make this number a bit larger, but you get the idea. So this was an introduction to set. We've also seen a number of combinations of set together with regex, how we can use regular expressions to further enhance our set use. And we've seen how set uses very similar, global and case insensitive and whatever quantifiers as we saw in VI. We've seen how we can do inline replaces directly into the file and how we can keep a backup copy. I hope you're ready for the next section.